We're delighted to have with us today the CEO of Albany International and a F-16 pilot in the Norwegian Air Force. I had to mention that. Albany International is headquartered in Rochester, New Hampshire, operates in two segments, aerospace engineered composites and machine clothing. Albany has 30 million shares, trades around $60 for a 1.8 billion market cap, 340 million of net debt for a 2.1 billion enterprise value. I'll sit down here and Gunnar and I will have a good discussion.
Thank you, Tony. I'll hang out with Marines any day, right?
Yeah, that's last option, right? All right. Maybe for those less familiar, could give an overview of Albany, this business segments, and sort of how it's evolved under your leadership since becoming CEO a few years ago.
Yeah, and the base of this business is really about weaving. The Albany International has 150 years of weaving experience. They have started several businesses, spun them off, and then about 20 years ago they decided to get into aerospace. And when they went into aerospace, they went into aerospace in a big way together with Safran by creating the fan blade and fan case for the LEAP engine. So very, very aggressive, very proud of that history. We're using our technology in weaving to weave a three-dimensional form and then inject it with resin. That part comes out of the tool and is essentially what you see on the front of the LEAP engine. This technology is a reason that I came here a couple of years ago. Unfortunately, in those 15 years plus, that has been the only development on 3D woven. The company has expanded in aerospace by buying a couple of more traditional composite facilities. They bought Harris Composites in Salt Lake, and they bought the Texas Composites in Boerne, Texas, outside of San Antonio. That facility is mostly engine related, fits well with what we're doing on LEAP. The facility in Salt Lake City is maybe more traditional, but we're proud to serve the warfighter there with a Joint Strike Fighter, the JASSM, LRASM, we have the CH-53K there as well. But I would say in the last 5 years before I got there, the focus was on growing that part of the business because there was a lot of opportunity. So I think the biggest change on the aerospace side was really getting in place a team that first knew very well what they were doing within structures. So I brought some people that I knew that knew how to build complex parts and very strategically minded, and that team got built out with that type of experience. But more importantly, shifting more towards how can we grow more profitably using this phenomenal technology that we have in 3D weaving. And 3D weaving is essentially, the LEAP blade is a perfect example of replacing a metal part with composites. The way we weave is completely integral to the part, so the part does not fatigue like a metal part. It also does not delaminate like a traditional composite part. It is a unique replacement to metal, which is why over the last 6 months I've been broadcasting and talking about how this is a perfect replacement to titanium. Titanium, as you know, takes a long time to develop. It comes from sometimes difficult places to obtain the sponge. It goes through several processes to become a titanium part, and there's machining, and then there is processing, and this can take sometimes years. What we have with 3D woven and injection resin transfer molding is a 100% domestic replacement to titanium. at a months of lead time compared to sometimes years with titanium. So that shift is going to take a while, because an aerospace engineer that is used to designing for titanium is going to continue to design for titanium. So we have to get to the engineers. We also have to come to the customer, because what we have in 3D woven parts is a lighter and stronger part than titanium, and we all know you need a light part in aerospace. So there's so much goodness around this, and just to show a couple of examples that have shifted in the last year for us is let's use engineers that are open to new technology. So in advanced air mobility, for example, you have Beta. Beta is a partner with us, or we are a partner with them on the composite part, traditional composite parts. It's a good program. It's a great growth program for us going forward. But they had challenges with their lift blade. They're starting out, their first few aircraft are going to be the standard takeoff aircraft. Yeah, just regular aircraft, except it's electric. And then they're going to move into the vertical lift. But they were having trouble with the lift blade. And that lift blade, we helped them design, and we used 3 of our technologies. We used 3D woven for the spar. We used overbraid over the end of the wing itself, and we used injection mold, resin transfer molding to finalize the part. What they got was a part that was 40 pounds lighter than their original design, and that kept its form during the transition phase, which is exactly what they look for. So it's a perfect example of how you can use 3D woven. The other one was highlighted at the Paris Air Show. We highlighted it, and our customer, Safran, highlighted it with the A350 landing gear at their booth. The brake brace, it takes 4 parts, and they're about that big, this thick, and this tall. Once they're painted, after we've made them, they look like a titanium part until you lift them, because they're a lot lighter. And on that landing gear, it takes 4. So in their stand, they had 2 titanium parts and 2 of our parts, and they were highlighting how important it was to get the weight out of that landing gear. So these are changes that are coming. They're not in production yet, but they're coming, in just good examples of where we're going.
Yeah, that's Gunnar, that's a great overview and sort of the long-term projection of this company, which I see a lot of success in the future. Maybe nearer term, key drivers behind the growth in AEC and the engineering composites business. You talked about some of these on your earnings call, but just going forward, just near term, sort of manage me through how we're looking here in the next.
Yeah, so it is our current program that's going to be our growth in the next 12 to 18 months. The LEAP blade and case is between 15 and or actually between 20 and 30% of our overall revenue. And you can see the growth there. I'm very encouraged to see the way Boeing is growing their 737 line. It is steady. They've taken their time before they move up. We're starting to see that pull from Safran on both the blade and the case. That is a big part of the growth in the next 18 months. JASSM, LRASM is a great program for us. We have put a lot of effort into growing our capacity. We're currently delivering 100% on time. Actually, on both of those programs, we're delivering 100% on time. And it's significant growth in the next 18-month period. There are a couple of other programs that have growth in them. CH-53K is we're going through the last push to get it up to the rate of 2 per month, and so that is part of our growth because we started pretty light at the beginning of the year.
we talked about also on the in the quarter. Obviously, I think there's quite a bit of overreaction, but the recent EAC adjustments at the composites, engineering composites business over the past few quarters. What, maybe talk about the latest status of those, and then secondly, the financial impact of the adjustments and to margins, and sort of how is that going to play out in the longer term?
Yeah, it's I agree with you that it appeared to be an overreaction for an $8 million charge on a program that still has 7 years left. But it is what it is, and I want to give a little bit of history on this. Our aerospace part of the company, the reason why I highlighted 100% on time, overall, we're 98.6% on time. And I challenge you to meet any company in aerospace that has that kind of performance. So when it comes to delivering piece composite parts, whether that is a part for the Joint Strike Fighter or for the LEAP engine, we are very, very good at it. And the company did make, as I mentioned earlier, the venture into more traditional structures. And that was the CH-53K. The CH-53K is a completely different program from anything else that we do. It will sail up to be a big program for us, which is why you're seeing some of the impact, the larger impact of it. But CH-53K is, we make all the composite parts, but the rest 4,000 parts we have to plan and buy. And so when I made the change last summer, it was because I was walking through in Salt Lake City, and I realized that I was having a problem that we needed to address. And I brought in Chris Stone to run that part of the business. He came from Lockheed Martin. If you look at us overall, Lockheed Martin is our largest customer. And he's brought in a team that knows how to do assembly. But it was an uphill battle because we had to get the planning right. We had to get all of the procured parts in. And that's what we've been doing for 1 year. And we have taken some charges through this. And we had a special call last fall when we said, this is what we have discovered. A lot of that was material. We have a very aggressive learning curve on this that we're monitoring every month to see how we're performing. The goodness that I see is my last visit to Salt Lake City was that we had parts in the jigs. The team was performing, and more important than anything is that we are delivering to Sikorsky and in the end to our warfighter to support that program. So the charges are there. They've been there. I understand them. I understand the reaction by investors on it because it's not something that you've seen before. But this is something we're going to work through. We are going to continue to deliver to Sikorsky and the warfighter. And in the end, make this program a good program. We got 7 years with full rate production to figure it out.
Maybe switching back to the LEAP program. They're talking about 25,000 engines expected to be built. Maybe more. Who knows? How is the supply chain right now impacting your LEAP business, just because it's such a monster? Right. And then what are maybe further opportunities or partnerships in that engine? I know that you have a very specific contract right now, but it would seem that someone that you can add the value that you can add, just seemed like there'd be more some forward opportunities.
Yeah, I think this is a great program for us. We're delivering at 100% because essentially what we're buying is fiber and resin. We have no issues with supply chain. And if you talk to any of, whether it's GE or Safran, they're very satisfied with our performance. And really this is about getting the cost right and continuing to do the ramp. It is going to, the one derivative from this is of course another growth program when Boeing certifies the 777-9X. We make the fan case for the biggest engine in the world. So, and that is another great example of how this is a GE engine. It's not a Safran engine, but GE came to Safran and us and said, that's the technology we want on this. So it's a 3D woven resin transfer molded part. It is also the largest resin transfer molded part in aerospace. So we can 3D weave and very good at resin transfer molding. The challenge with the contract with Safran is we can only work with Safran on engines and landing gear. We can't work with anyone else on that. So that's why our focus on growing 3D woven is outside of that. More parts that you would see on newer aircraft where they're replacing titanium. But that doesn't mean we don't have opportunity within, for example, the LEAP engine or other engines. There are places around the engine where weight is a factor, and this is something that we definitely is exploring with Safran. They have a new CFO. They have a new CEO, and Stefan and I have been meeting. Once we are ready to see where we're going, we'll come back together.
Maybe back to 53 now. I think you touched on it lightly, but could you talk about the ramp up for the 53 kilo, expected timeline to full rate production, and then how are you managing the capacity for production? I mean, this is going to be a big program for the Marine Corps capacity.
Yeah, and we are ramping up now this fall to get to the full rate. There are some of our product, we make the whole, anything aft of the cabin all the way back to the tail rotor is made by us. It leaves our factory fully painted with Marines on the side. So and all of the warnings and everything. It's great to see it there. Some of those, like the sponsons, the TRP is what they call it. But anyway, we're at rate. Really, our biggest challenge is the biggest part, which is the empennage or the aft end, and that's where we're putting in the effort. We just we continue to hire, but I think we're at the rate where we now just have to get our productivity where it needs to be and continue to deliver, like we said, to Sikorsky to support the program.
Jet guys can support chopper guys too,
there
right?
Times.
So maybe back to the Paris Air Show and talking about opportunities. You talked about titanium. I mean, I remember lifting the brake brace. I thought I was going to weigh a ton, but you could pick it right up. It's this huge piece of gear. What other? You mentioned that, and you talked about some other things. But what are some advancements in composite materials that sort of allowed this to happen? Maybe give us a little quick background on how you were able to figure this out, that, hey, I can essentially do anything that titanium can do. Where'd that come from?
Yeah, it's... I want to start with Paris Air Show because for those of you that have seen us before at Paris Air Show, it was a very market change in how we went to market, and it was all about replacing titanium. The R&D function within the company has put a lot of effort on being able to weave certain shapes and that can replicate where titanium is used today. But we have not actually gone out and marketed it. So this is a huge opportunity. There are places where we can't replace it titanium because we have to be a little bit thicker, in some cases. So there are even though and this is what's exciting, right? The titanium market in 2035 is going to be $40 billion. I don't think we can take it all, right? But it is. There are places on the aircraft that is titanium today where we are a perfect fit, and we're trying to highlight that to some of the new entrants like MV75, NGAD, CCA. What we come with is a proven solution, and we're also commercial. We can make 30,000 fan blades a year. So clearly we know how to do this. So this is something that that we can go with a solution to our customers.
You know, I didn't hear that. I didn't know that part about thickness, but it makes a lot of sense. But is that a relatively small portion of, you know, whatever capability that you have to replace titanium? Is it almost everything can do it the same size, like same specs, or is it just a small part of it?
It is a different way of designing the part because of it is not a metal, right? So we have software that takes all of the demands of the part into consideration, and we can do the design and show how we can replace a same part in metal. But actually, there are places where we can replace aluminum too. And there are certain geometries that are more difficult than others, and so there are some places where maybe we are more expensive, but maybe the customer is willing to pay more to get the weight down. And there are other places where we're cheaper. So finding that, I can't quantify how big that is, but we will not get there unless we start really exploring that, and that is. I think this is a growth, and what I've talked about, I think I talked about it last year here. Right now, we have a few examples that I mentioned earlier. That is right now, you know, Beta, Safran. So on the other one that is really near, which is really not titanium replacement, but it's similar. We're using 3D woven to create a near net shape part to then densify and carbonize to make parts for hypersonics. So not only can we replace titanium with this technology, we can make a carbon part that is near net shape. Today, most of these parts are made as a block, and it's machined away. It's very expensive to machine it away. So the near net shape is starting also to get some attention. We've done a lot of investment in that. Very excited about where we're going there. I heard earlier they were talking about the Golden Dome and so forth. There is not an industrial base to support the hypersonic industry in the U.S., and we have a solution there as well, and we're capacitizing for it. So that's the second one. The third one is really all these aircraft that are popping up from the need of the warfighter, whether that's a CCA or NGAD or MV-75. It's hard to say MV-75 when you've built the V-280, but these are new aircraft that all will have a need for strength and weight that we need to get in with at the front, and where we're having current discussions, right? And the last is the future goal, and the future success is really the next single aisle, because we're already in talks with Airbus. We've shown what we can do on the wing of tomorrow. Obviously, we're working with Safran and GE on the next generation single aisle engine. So there's a lot of potential with this, and it's just too bad that the focus hasn't been there yet. We have to deal with where we have been growing, but the focus of the company going forward is going to absolutely be around the 3D woven.
I mean, and pretty much the only limitation is, like we said, I mean, certain temperatures, obviously alloys will be needed, but besides that, those small parts, everything else, and then you have the potential, it's feasible to back engineer, to reverse back engineer into older legacy potentially, and then just going forward, all the swap, you know, all the capability going forward.
Exactly, and we have looms, we have capacity because of the development that we've done with Safran, and we have space. So it's good. I want just one thing: high temperature. So we're already doing the carbon, but the core of the engine, and especially the military engines, are going to be so hot that metal is not going to work. So then you have the ceramics, and 3D woven has a place in ceramics as well. It's not something we have developed yet, but being how far along we are on the carbon, that is an opportunity as well.
Very interesting. Maybe I'll open up the questions to the audience.
All All right, we got a couple of questions.
Just two quick ones from me. One, can you talk about how much you're spending right now in R&D as far, as just developing your composite materials? And also, second question is, considering where the stock is right now, have you considered a stock repurchase, stock buyback program as well? I know you guys are giving out a dividend, but just curious about that.
Yeah, it's good question. So let's first, we are continuing our dividend program with 27 cents a quarter. After second quarter, we had bought back 94 million worth of our own stock. We have I think it's 140 million left on our authorization to buy back after the second quarter. The first question, sorry.
Can you talk about R&D? How
Yeah.
much are you spending?
Yeah, R&D, to be able to do what we're doing, we're spending a lot on R&D, between 3 and 4% on both sides of the business. We haven't really talked about machine clothing, but machine clothing is a goofy name for the very advanced belts that go on paper machines and other type of machines. To be able to be the market leader in that product, in that segment of the industry, you have to continue to invent. And I would submit that all of our competitors are copying us. We are a large portion of that market, and we have a price premium there because of our technology. So R&D spending is high relative to other companies, I would say. Go ahead.
All right. And then, it sounds like even in the case of replacing titanium parts, right, with the composites, there's still a redesign associated with the part to make sure all the engineering and so on, and the math works out.
Yep.
I'm curious at your experience in kind of the cultural adoption of replacing this part, something that is comfortable from an engineering perspective.
Yep.
With regards to and replacing that with a composite part that has less comfort from the engineering side, at least from a program office kind of perspective.
It's good. So it's a very good comment and an area that we are addressing. How many engines did you say? How many LEAP engines?
I mean, there was discussion of 25,000, I mean, in theory.
18 blades on each of them. We make 30,000 a year. The technology is proven. So we need to go all the way to the Hill. We need to go to Pentagon. We need to go. And we have hired lobbyists. This is an all-out effort. It is not a short effort. I think the hardest part is to take current titanium parts and redesign them and put them into aircraft. That might be the hardest part. It's better where we come in front. But it's encouraging when you talk to engineers that are, like Beta, that said, yes, please, we want it, because they see the benefit that we're bringing to them, and they believe in our story with the LEAP program. I wish I was 5 years down the road, but this is going to be an all-out effort. And I recognize for all of you, if you have stock in Albany, I have to deal with the CH-53K, and we'll deal with the CH-53K.
Gunnar, you've done a great job. Thank you for coming today to talk to us, and it's always great to have a fellow fighter guy up here, and I hope we get you back next year.
It's good to be here. Thank you for inviting me.
Thanks,
good to see you, Tony. All right.
Investors should carefully consider the investment objectives, risks, charges, and expenses of the ETF before investing. The prospectus, which contains more complete information about this and other matters, should be read carefully before investing. To obtain a prospectus, please call 800 Gabelli or visit www.gabelli.com. Risks to the ETF include a downturn in commercial air travel, production and/or supply chain disruptions, decreases in defense spending, subcontractor financial health, and competition and/or technology changes.